Yeah, good morning all. Am I audible?
Yes, sir, you are audible, sir.
Respond on that. Am I audible?
Yes, sir, you are audible, sir.
Am I audible again? Yeah. Hello?
Yes, sir, you are audible, sir.
All right. Online में भी आ रहा है. Okay. Good morning all. I welcome you again. First of all, I would like to thank Dr. Mridul Sahu for inviting me and sharing my experience towards the data science that I have earned till date. And without uh, wasting much of the time, I'll be directly digging up what we are going to do for the day. What I have planned for this session is I have also a data set that has been given by Dr. Jharia sir from the geology department. He has given me a data of pre-monsoon and post-monsoon waterfall data, water level data, which is collected across 71 district from the Chhattisgarh. And that was like the level of water level at various wells that are placed across 71 districts in the Chhattisgarh. And that data was collected both before monsoon and post monsoon also. I'll give the like introduction on that data also. And since it's all about data science, so obviously we'll start with the introduction of the data science. And throughout the lecture, what I'll do is I'll also have some theoretical session on my writing board. And parallelly, what I'll do is I'll switch on to the laptop so that I can show you the its practical implementation and how the effect of various parameters or what are the theoretical things that we are learning is actually reflected into the implementation points. Okay. So during the in fact, not only we will not be restraining ourselves into a single data set. There we have like I have used, since actually the problem demands that I would be applying some data pre-processing technique. So obviously not single data set is carrying all the requirements that I'll be dealing in this session. So I have used multiple data sets, and I'll also introduce those data sets when we will be dealing with that particular problem during that session. Okay. But first of all, let me start with the basics of data science. And for that, I'll simply take the help of my browser and simply search what is data science. And for that, obviously, any topic that you search and the first topic that comes from the Wikipedia, and that would be a reliable source to which I can rely on for getting some basics about the particular topic. It says, if I search data science, it says it's an interdisciplinary field that uses scientific methods, processes, algorithms, and system to extract or extrapolate knowledge and insight from noisy, structured, and unstructured data. Some scientists has also given the data science is a field where mathematicians, statistician, and the computer programmers, they unite and together form an area called data science. If I go to the details, so like the definition that I read, it says that it will obviously be carrying some processes, some algorithms, which will be extracting knowledge from the data, okay, so that the auxiliary data or the dead data which was present now will be used for extracting the information, for getting some information from the data. Okay. And obviously there are like here in particular definition, it is also mentioning some types of data like noisy, structured, and unstructured. I'll tell you like how these data are categorized into these categories: noisy, structured, and unstructured. But before that, we have to also see what is data. Okay. And for that, I'll minimize it. And as I said, I have data set given by Dr. Jharia, which is this welldata.csv. I hope it's visible. You can see that it's a format which is in the .csv file, which is having name well underscore data. It carries 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 columns and 71 instances row. I'll call rows to be instances and columns to be like attributes or feature. Okay. And if you see, the first column is about serial number. The second column is about longitude, latitude, location, elevation, parapet, diameter, water level, pre-monsoon, water level post-monsoon, water level in the month of June 2021, water level in the month of November 2021. Then there is also called water table index for June 2021. And the last column is your water table November 2021. This is the real world data set which has been collected from these 71 districts. Okay, the location district. And it's like GPS values like longitude and latitude values are also given, okay, which is corresponding, like it is directly corresponding to the location itself. It means that these three columns are denoting the same thing. Like from the longitude, latitude and location, we are getting only a single information that is a location. Okay. And then the rest of the parameters for a people who are from geological department, they would obviously know about these parameters, like what is the elevation, parapet. In fact, to understand this, what I'll do is I'll simply write parapet and elevation of well. Okay, I hit enter and go to the images. In fact, let me write only parapet. It's basically the circumference, I guess, like this diagram. It's basically this circumference, like the inner core and the outer core, the length. I'm also not sure, but yeah, here it is written a parapet around if the length of the outer edge. So it's basically the distance from the inner edge to the outer edge of your parapet. Okay, and the different wells that were used for the collection of this data from the various location having different elevation, different parapet and different diameters too. Okay, and based on the various physical, I can say these three columns to be the physical characteristic of my well. Okay, the rest of the values are collected based on the that on the particular day, that is pre-monsoon day or the post-monsoon day. Obviously, people went at Sarsinagar. Okay, they computed these values and they noted the water level before monsoon, post monsoon. Similarly, June, like in the month of June, then in the month of November, and so on. Okay, so this is sort of live data. And as a data scientist, what I have to do is I have to use this data to get some information about like what the things that I can make some predictions for the future values, or make some inferences, extract some knowledge from this data. Because for an end user, okay, or for a layman, it is something which is a table arranged in form of rows and columns, where rows are giving me district values and like various parameters associated to a specific district, and the columns are giving me some attributes or the properties which can be interpreted by just seeing their titles and seeing their column labels. And in fact, this is the best example of structured data. Okay, I hope you remember when we saw the the data science definition, it is clearly written here, structured and unstructured data. So this is one of the example of structured data where your data is present in the form of rows and columns. Okay, and each row I'm naming it it has to be instances, and column would be called as a feature. Okay, in the case of unstructured data, it would be like your your log file, web log files, which are like you need to apply some pre-processing to get the original data. It's like raw data. You apply some pre-processing to get the final, like your pre-processed data. Those types of data are called unstructured. There is also one more category which lie between structured and unstructured, that is called semi-structured. Your the data arranged or extracted from some heterogeneous sources, like you have multiple sources of the data where some may be giving you structured data and some may be giving you unstructured data. The collection of the data would be known as semi-structured data. Okay, we will be focusing right now only on structured data. Okay, because I want right now a simple model. As a beginner, what I need is I want a structured data where this data could be used for information extraction. Okay, and that could be done through various data science algorithms or your machine learning models. Okay, see, as a first step in the data science, what we see is there are few steps which are very specific in every operations that we do in the data. Like every whatever, whenever we will be applying data science, or whenever you want some information or extraction, your data extraction or information extraction from the data, you would be going through certain steps which are like this. It's not switching on my like iPad.
Stop preventing from the
Achha, okay. Yeah, is my screen visible?
just go to Google Meet when this
Yes, sir,
system
visible.
Google Meet meeting on.
Yeah. Okay.
Now, and we can also make it a full screen mode. The three dots. Okay. Change layout. No. Change layout. Okay.
ठीक है ना, तो full screen okay. Okay. I said that there are certain steps which are very common in every data science application, and those are, I normally remember it by a code called OSEMN, where O is the obtained data, S stands for scrub data, scrub the data, E stands for your EDA process, that is exploratory analysis, that we'll see in a while, exploratory analysis. Post exploratory analysis, what you do is you try to model the data, or you try to form a model which will be going to work on the data. And then post modeling, you will be integrating model and validating the performances. Okay, so these are the some common steps which will be always there when you are applying data science onto any application. Okay, so I expect that I have obtained data from a reliable source, and which is giving me right now structured data, like the case of my well data that just now I have shown you. Okay, that is in structured data, which would be obviously in the form of a table carrying m rows and n column. Well, rows will be denoted by or named as instances, and columns will be named as features. So one thing is clear, that I need a data set for the first step, and that I have right now. The second thing, which would be scrubbing the data. Scrubbing is something like data cleaning. If you have noises in the data, now what kind of noises can we have in the data? Let's see some noises. For example, in this particular data that I have shown you, probably there would be a situation when someone called me or called the person who is collecting the data on a certain day, probably on Tuesday of a week in a June, and because of some busy schedule, I was not able to reach over there. What happened is on that day, I was not able to collect the data. In that case, if I see my data set, there would be situation like missing values could be there. Missing values. Okay? This is the first kind of noise that can be present in the data. Second could be your values which are not in the normal range. I mean to say outliers. Okay? Outliers. We'll see with some examples also. There could be the possibility of outliers. Then the third thing could be there are variation in the ranges of various attributes. Now, what do I mean by this is, suppose the first column is in range between 0 to 1, and maybe the second column is in the range between 10,000 to 50,000. And probably the third column is carrying the range from minus 5.12, say, to probably 50.45. So all the three columns are there with having different ranges. This could be also one of the situation where model needs some kind of tuning, needs some kind of data pre-processing, which would be achieved by, or in fact, I'll give the solution later on. Let's first discuss what could be the tentative the problems that can be there in the in your data. So we have missing values, we have outliers, we can also have the variation in the attributes. What else we can have? Any idea what else we can have? Like if you see the data, obviously these are the things. Then there would be the data representation problem could also be there. Now this is very simple. It's all because if you see the well data which I have shown just now, you might have noticed that location wala column was carrying some string values, the name of the district, and then rest of the columns, major of the columns were in the range carrying real values, which is your decimal values, and obviously those are numeric values. Okay, and it also happens many of the times that many of the machine learning model would not be able to run onto the strings that you are going to provide. In those cases, what you have to do is you have to perform some sort of encoding techniques, or in fact, we can also call these strings to be categorical data. I'll come to this point like very soon on that, like what is categorical data. And then to deal with those categorical data, we have to look for some encoding techniques. These encoding techniques, you might have also listened about your ordinal encoding and then nominal encoding. And in the nominal encoding, you have very one popular method called one hot encoding technique, OHE, one hot encoding technique. Okay? So like this is tentative solutions through which you can actually handle some of the problems which may be introduced because of presence of noise in the data. Okay? Noise. I consider all these situations to be noise. Majority of authors consider noise to be only missing values. Okay? Only missing values are referred as noisy. But I consider all these, like there could be more situations, but every time, like every situation would be landing me in a situation where my model would not be able to learn very well the data. You know? Okay. So in this context, what I'll do is I'll like first of all introduce the data type, which is basically categorized into two, that is numeric and categorical. Numeric would obviously like you have discrete value or real values, both can be inside numeric. And in the categorical, it would be like you have some strings. Maybe example could be your color of a car. Color of a car could be either red, green, blue, okay, or your grades, which can be represented by O, A, B, C, D. This is also like you have categorical data, okay. So primarily you have these two types, numeric and categorical data, in the structured data type that you have in the structured data set, okay. Further, like numeric could be further divided into your discrete, which will be carrying only values, non-decimal values. Then you can also have real values, which will be carrying decimal values too. And then a special type of discrete, which is also called binary values. It will carry only 0, 1 value in it. Okay. And if I see my data, which one? The well wala data. I have the first column was my serial number, which was completely discrete. If you remember, it was a serial number till 1 to 71. Then the second one was longitude. Then third one was latitude. I guess they were also discrete. Fourth one was location. So that was categorical. Okay. Fifth one was your water level. Then so on. All the rest of the parameters were real values. Okay. So I hope you can connect these things. What is discrete? What is real values? And what is your categorical values? Okay. Now, when I get the data, like my first step was I got the data, which was your obtain the data. And now obviously I'm looking for scrubbing the data cleaning. And for that, I have to see, or in fact, I have to apply some analysis before cleaning the data. I need some analysis, and that would be on two criteria. One would be univariate analysis, and then the other one would be multivariate analysis. Okay. Multivariate analysis. What I'll do is, instead of giving the theoretical definition of univariate and multivariate analysis, I'll directly switch on to my Jupyter environment. And give you the examples of univariate and multivariate analysis. So this is what I'm doing this thing is to understand the data, what the data is about, okay, and what the next step that I have to perform on the data. For that, I would be first thing what I'm doing is I will be going for univariate analysis. And for that, I have already a Jupyter file. Yeah, this one. See, there are some libraries that you have to go through to understand why, some basic functionalities. The first library that I have used over here is that called pandas. Okay. And if you are not familiar with the pandas, let me go and write pandas. I'll go to the mother website, which is pandas.pydata.org. This is basically used for importing data sets into the environment in the form of data frames. Okay. Data frames are nothing. They are like your rows and column only. There will be a table. Okay. And like any data that you want in your environment to be like work on that data, you need to call pandas library. Then this is not only for loading, it also provides lots of other functions that you can operate onto the data frame, so that some pre-processings can also, like you want to delete some rows, that can be done with the pandas. If you want to add some rows, that can also be done with the pandas. Okay, you want to access the rows, that can be also, in fact individual cells can be also accessed from the. Apart from that, there are many functions inside the pandas, but what we have to do is we have to only see the requirement of our applications. Okay, and based on the requirement we need to call the corresponding functions. Like, see, okay, I should have introduced this environment to, this is a Jupyter notebook. Okay, here what you can do is you can run your commands in cell by cell mode. Okay, where right now the first command, that is import pandas as PD, is basically a library pandas which would be referred in a variable called PD. Okay, now instead of writing pandas everywhere, what I can do is I can directly write PD. Sirf mujhe PD likhna hai, and then like pandas will be called. Okay, and in fact you can also understand in this manner, it's sort of object, and like PD is an instance of that object. Now through that instance you can call the various functions which are already there in the pandas. Okay, so let me run. For running, either I can like go to run, or you also have some options over here, like cell by cell run karna hai, so you can just go and run cells. And if you want to run all, every commands will be run. Okay, but I would be running only single cell right now, because I don't know right now what is this functions all about. Okay, and why I am doing all these things. So I said, like this is my first step. I'll understand my data, what the data is about. Okay, and I'll be performing these basic steps. So let me run the first statement. When I run it, you can see the difference that the rest of the like extreme left side, there's a statement written in, then you have square bracket, and inside that square bracket, the rest of the values are empty, like row 2, row 3 are empty. But before running it, the first cell was also empty. When I ran it, the value changes to 1. Okay, it means the statement is successfully run, and now this pandas is imported into the PD instances. Okay, let me run second cell. Right now the cell is the empty matrix. When I run it, it is now represented by 2. Now what we're doing is, see, in pandas we have a function called read CSV, which takes the file name train.csv, which is already there in my folder. Let me show you that folder too. It's basically, I guess it's in users. Yeah, lectures. And then I have some data sets already with me. Well data bhi maine isi pe rakh liya hai. And then right now I'm importing which one? Train.csv. Let me go to train.csv and show you what is this train.csv is about. Yeah, this one. See, it's a data set which is a Titanic data set. I have downloaded it from Kaggle. I hope you know Kaggle. Basically a competition website where one uploads his data, opens a challenge for the developers who are present across the world. Okay, and they're like, initially they also throw some prizes, not directly in terms of in monetary issues. They also provide like some credits, or like it's basically a challenging competition, where a competition website where the data set will be open for the for the development, or for the seeking of a solution, better solution from various developer which is present across the world. Okay, in fact you can directly write Titanic over here to get the Titanic data set, and this data set is about the person who survived or who does not survive after the Titanic collision. Okay, it's about the first column is your passenger ID. Survived is the column which is a binary column stating about the status of that person. Zero matlab that person wasn't survived. One, that person was survived. Passenger class, because the ship was very huge, it was like discriminating people with the classes: third class, second class, first class. First class has privilege of having their own cabin. Third class wale people was like there was a common lobby, and there they have to, like, some, you might have seen the movie as well. Okay, the name of the person, that passenger name, gender, his age, sibling or spouse. Okay, like whether the sibling hai ki nahi. Okay, that guy. Then parent is accompanying or not, ticket number, fare, cabin allotted, and then embark is something from where he actually started his journey. Like S stands for Southampton, C stands for California. So like there are three places from where the Titanic like started, or the passenger has started their journey. Okay, so I hope like you got the idea of this data set, and this data set is about, you have to like predict, given on the row, on a particular row, that whether the person is survived or not. Okay, so they basically, this problem can be formulated as a binary classification problem, where you have to build a model which will take input a row and predict whether the person will survive or not. Okay, okay. Suppose I got this data, and now I said that obviously I'll do what the initial or the first analysis that I would be doing is, what is the shape of my data? And for that, I have a variable associated to the data frame, which is called df.shape. This command is saying that rows are 891 and 12 columns. You have 891 in passengers, and each have those 12 attributes associated to those. Okay. Now, I also want to see what are the information that is there in the CSV file. Okay. So for that, I have a function called df.head, and I'm passing 5 as an argument over here. What this will do is, it will give you the top 5 information, or top 5 rows from the data set. This is the like passenger ID. It's the same CSV file, but now because of this read CSV, this CSV file is uploaded into a data frame, and its variable is now known as df. Okay, df. df.head5 is giving me the top 5 rows, top 5 instances. And sometimes what happens is, from the top 5 rows, you cannot infer that what kind of information is carrying in that CSV file. For that, I have a function called sample, which will give me 5 rows randomly from the CSV file. When I hit enter on df.sample5, the first instances was given for 514th row. Second instances is 149th row. Third is 745, 530, and 346. This isn't the case when you have, like, suppose the structured data that you have is already arranged in such a manner that top 5 rows are for survived classes, and the last 5 rows are for the unsurvived class. So you can't get the idea. Sample is something which will give you a random amount of instances from the whole data set. Okay. And obviously 5 है मतलब 5 instances. If I do 10, so like you will get the 10 rows. Okay. The next thing is, what are these data is? Like, okay, I'll run it and show you. Which column is of which type? Passenger ID is basically integer. You can see, like, it's basically a discrete column. Survived, because it is carrying 0, 1. Again, it's actually integer. Then the name is object. Okay, because string class object. Again, your gender is object. Then you have age, which is represented by the real values, and so on. So this info is basically giving you the attribute informations, every column information. Okay. Now the next command is about whether do I have any missing values in my data set or not. Okay, I'll show you. Instead of dot sum, I'll directly run it and show you. But it is saying that for each cell, it is looking for not a number, not a number. Like there is nothing missing value hack any. Okay. So right now, wherever you're seeing false value, it means there is not a number. Like there is a value over there. There is a value. And if you see true, there are some true values. You can see inside the cabin wale column pe, you can see there are true, true, true. It means that those true wala value is basically carrying not a number or a missing value. Okay. So I have missing values in cabin. Can you tell me any instances like where cabin value could be missing? What is the situation? Yeah, if the person is of third class, okay, like don't interpret in that manner ki it's a person third class. It's like person category is third class, okay. So obviously he would not be allocated a cabin. In that case, cabin wale column pe kya hoga? That would be a blank value, which would be treated as a missing value. By my machine learning model, it would be treated as a missing value. Okay, and which is fair enough. Okay, so this is null is recognizing what your missing values in the data set, and the dot sum was what the dot sum is doing is it is actually summing up the column values. How many null values are there in that particular column? You can see that age wala column is carrying how many null values? 177. Okay, and similarly cabin wala column is carrying 687, not a number values, that is missing values. Okay, so like this is why I took this data set, because here I have a noise which is a sort of missing values. Okay, and because there is a reason why I took this data set. In the second session, where we have to deal with or discuss this particular like a referred article, for that I have chosen a paper from a very reputed journal called Knowledge Based System from the Elsewhere. It is like published in the year 2022 only. It's a very recent paper, and it's about, you can see the title is about deep learning for missing value imputation. I'll come to that point. Imputation, what is imputation of continuous data and the effect of data discrimination. Okay, so this paper is dealing with a problem called missing values. Okay, and to understand this paper, obviously we need to also know the basics of what is the missing data and what is actually the imputation is. Okay, so that's why like I'll come to this paper later on, probably in the second half of this session. But let us continue the the noisy part, which is given by this age and cabin factor. Okay, a cabin attribute. Okay, the next is describe. This will give you some statistical properties related to each of the column. df.describe. It says how many total number of instances are there for the passenger ID, that is 891. It's about counting the number of rows. What is the mean value of that particular column? Standard deviation of that particular column, minimum value, 25 percentile of the total values. How many, like 223.50 value are your comes or 223.5 or lesser than 223.5 will be your data, which is 25 percentile of the total data. Okay, similarly for 50 and 75, and then the max value. This is like very basic statistical information that you get after hitting describe function for a data frame. Then the next method is about checking whether do I have any duplicate row, because if you have duplicate row, it means you're simply wasting your time for or you're wasting your machine learning model for additional mathematical operations that you need to perform for any specific like algorithm. Suppose you're trying to apply your decision tree or SVM or any other algorithm, obviously if you have multiple entries of the same row, the computation will be also multiple times. So this is also very important step to check, do I have any duplicate row or not? Right now it's saying 0. It means this data set does not have any duplicate entries. Okay, and then this is about again like what we are doing is we are about to explore the data. What kind of data set do I have right now? And then this is something which comes under my univariate analysis. Okay, univariate analysis. What I am doing is, you might have remembered that while uploading this data, I have a column called survived, which is carrying only two values, 1 or 0. Okay. And what I'm doing is, I'm calling basically a function called correlation. Okay, correlation, which is something like I want correlation of survived column with all rest of the columns. Okay, let me run and show you. It is like, how many values are there? See, 1, 2, 3, 4, 5, 6, 7. 7 columns, like 7 values are there. And like, if you remember, there are total 12 columns were there, but here you're getting only 7 columns. There is a specific reason behind that. Can you tell me, like, what is the reason? Because rest of the columns which are not included over here are, for let's say, name के साथ correlation. Name is string value, है ना? तो the string value could not be correlated with the numerical value, so that's why the rest of the columns are skipped. But rest, like passenger ID was your numeric value, survived was your numeric value, passenger class was numeric value, and so on. And you can see the trend that the values are in the range of -1 to 1. Okay, if the value is 1, यहाँ पे देखो value एक आया है, survive value is 1, it means that particular column is highly correlated. ठीक है, highly correlated if the value is 1. And in fact, I would also like to add over here is, it's actually highly positive correlated. ठीक है, positive correlated, it means कि it's like, imagine the situation कि the higher the CGPA, the higher will be your LPA, lakh per annum package. Okay, higher the CGPA would be, and higher the lakh per annum package, placement package. Okay, and there would be also situation where your correlation could be -1, which says that ki the value would be stating about its negative correlated. उस केस पे क्या होगा? Negative correlated is something like the like inversely proportional kind of thing. जहाँ पे you have can you tell me any example on this? Where the one variable is basically increasing, the other value would be decreasing, and the lesser would be the LPA. Yeah, that could be also, but outliers are there. Outliers are always there. Sometimes happen like कि जो backlog है वो, sometimes you feel that he is very much settled in his life, है ना, after a certain period because of his experience. ठीक है, and so that comes under the outlier, but that could be one of the example that we can like consider in this situation. Ki negative correlation is something like one variable is increasing, which affects the other variable to be decreased in the same proportion. Okay, so -1 is negative correlated, 1 is positive correlated, and 0 is something which has nothing to do with the correlation. Like it has like that particular column is not at all correlated with the data. Okay, if your column is towards 0, okay, you cannot make any inference about those columns. Okay, what I am doing right now is I am actually associating my survived column with rest of the columns. So what basically, this is the first step, that I am analyzing my survived column with rest of the columns, and this is what we call your univariate analysis. Okay, I hope you got this idea. In fact, what I'll do is I'll do some changes over here and run the same for my well data too, well data.csv, and now this time let me run for all. Okay, you have, I said 71 district, 13 columns. Okay, this is your, okay, this was created, cut. First top 10 samples. Okay, not top 10, in fact, random 10 samples. This is information about my attributes. Then checking whether it is carrying any null value. So that data set is very well prepared. It doesn't have any noisy and like any missing values. And then describe basic statistical information. Duplicate bhi nahi hai. Okay, I got here, obviously यहाँ पे आएगा है because survive is not a column in my data set. In fact, I can take which column? Let me take this one. parapet. See, you have now correlation value with respect to the parapet. Okay. Uh, this is what we do with the initial steps, like when we get a data and try to infer some basic information about my data set. Okay. Next thing is, I would now extend more towards the univariate analysis, where I'll take some help of the basic plots, and through those plots I would now try to explore the hidden relationship that is exist in the data set. Okay, for that let me upload my next. Yeah. Now what I'll do is, with the help of Seaborn library, I'll plot some, like I'll in fact use some visualization charts and plots for understanding the data. And for that, obviously this data set is again Titanic data set carrying both categorical as well as numerical data. So first thing is, we will first univariately analyzing on categorical data, and then we'll move to the numerical data. For the categorical data, the first plot is count plot. I'm not explaining this functions. What I'll do is, I'll hand over this Jupyter notebooks to you all. You may simply run on your Jupyter notebook and just have your this pandas documentation with you to understand the various functions associated with various functionality associated with each functions. Okay. Okay, so count plot is taking, if you remember, I said embarked was something like 3 cities were there. From those 3 cities, how many people uh, started their journey. Okay, so these are the, like, your amount of people from the Southampton is the city where maximum number of people started their journey. Then California, and then O is like some which place hoga, I don't know its name. Okay, so the least number of people started their journey from O, and then maximum people started their journey from Southampton. So this gives me an idea, okay, that like when I'm seeing that column, I am not getting any sense of idea, but with the help of this bar chart, now I can sense that okay, amount of people are major from the Southampton. Okay, the same thing can be also done with the pie chart. Okay, if I like say do the this pie chart formation onto this embark wala, so I would be getting over 3 colors here, but this is for only analyzing the gender. So from that, we came to know that approximately 65% of the people are male, and 35% of the people who are there in the Titanic are female category. So this is again giving me some rough idea about the population. Okay, the kind of people who are there in the Titanic ship. This is about your categorical data. When I try to analyze numerical data, obviously the first thing that would help me is histogram. And it's very important. Like histogram plot is something through which you can analyze a term called the distribution. Okay, I'll come to that point, see how. In this command, what we are doing is we are interested in age column. Okay, and I'll like want to see the frequency of a certain age people. Okay, like how many people are at age between 30 to 40 who are traveling in the Titanic ship. Okay, so that would be done by the histogram plot, where the commands is hist, and you have to supply the column, and additional argument is your bins. You want total 40 bins over here. Okay, 40 bins. With that, you can see that this is a particular histogram plot which gives you an idea of how your data is distributed in that column. This particular chart is right now giving me an idea that there are majority of the people in the Titanic who are in the age between 20 to 30. younger people are more in tightening data set. 20 से 30 वाले सबसे ज्यादा है इसमें. Okay, and you can see that there are also few people who are near to 80, and there are also many like your children's, okay, which are from the like 0 to 10 also. Okay, so there are also few children's whose like whose age are not mentioned. They might be in the months mein honge. Okay, and then we also saw that there were approximately 72 indices which were carrying missing values. Okay, missing values too. So this gives me an idea of distribution, and it plays very important role in any of the machine learning algorithm. You can imagine this situation in this manner, like somebody, suppose as a data scientist, I expect that you would be coming up with a model for a data that I provide to you. Suppose I give you a data for predicting the winter wear sale forecasting, winter wear sales forecasting. Okay, and like as a user, I gave you the data of my particular shop of a winter wear selling from the month of your, imagine, September से लेके मार्च तक. I gave the data for the developer to the developer from the month of September to March. Okay, and expect that he will come up with a machine learning model which will take certain instances and predict that what would be the selling of winter wears in the month from April to the coming months. The difference is like, see, you somehow you took the data, you come up with a model, and your model is giving accuracy of 95%, let's say. But that model is giving the accuracy of 95% on a data which is collected from the month of September to March. Okay. And if you see the distribution, the data distribution in the sales wale column pe, from the month of September to March, it will be like a normal curve, where the highest sale would be in the month of December and January. फिर सेल थोड़ा सा नीचे आएगा फेब मार्च में, it will be towards the it will be like a plateau, mountain kind of. ठीक है, जहाँ पे the middle one would be your January December, and the like जो extremas हैं that would be your September वाला and the March वाला month. ठीक, and now you gave your machine learning model to the shop owner, and now he's trying to predict for the month of April, May, and June. What will happen? Because since the data that I gave him was having so much of data distribution difference, that's why my model will fail. And this data distribution for a particular column can only be interpreted by this histogram plot, okay, which is also called your KDE, like this plot, kernel density estimation plot. Okay, this is a curve, a continuation curve, which is just joining your histogram plot, which is like a continuous curve sort of carrying the area of your histogram plot. Okay, so just imagine that this blue curve is your distribution curve of that particular column. So imagine training data ke liye, if you have given a normal curve, and testing ke liye you're giving uniform curve, so obviously there would be a difference in prediction. Hoga na? Are you getting my point? Uniform curve would be like what? Since April में भी 0 होगा, May में भी 0 होगा, June में भी 0 होगा, so that is a uniform curve, uniform distribution, and you have trained your model in a normal curve. ठीक है, normal curve would be looking like this only. ये जैसे दिख रहा है ना अभी, this is not exact normal curve because here you have multimodal, है ना, दो maxima दिख रहा है मुझे अभी right now. One, this area is local maxima and this is global maxima. This is not unimodal. Unimodal में there would be only one maxima. ठीक है, तो multimodal पे obviously थोड़ा सा again there would be some difficulties, but we'll not deal with those things. There are many things to deal with those situations, है ना. You have to rely on a theory called your a very widely known. You can, what you can do is you can convert this non-normal curve to normal curve with the help of. I am forgetting the name of that theorem. It's very popular theorem. Anyhow, when I'll come to that on the second session. Like if I recall it, okay, its name is very, like, it's very popular in the sampling distribution. What you can do is you have a non-normal curve. With that non-normal curve data, you can actually transform your data into the normal curve. Okay. So once, see, as a machine learning model, if my data is producing normal curve, I will be very happy as a data scientist. Okay. I want a situation where data would always be in a normal curve. If the data is in normal curve, मान लो कि आपका आधा काम हो गया, ठीक है. But if the data is in not in normal curve, ठीक है, it's not in normal distribution, तब you have to make some exercise, like you have to lots of exercises for getting a appropriate machine learning model. Okay. Similarly, we also have box plot. Box plot gives you an idea of an outliers. Here you can see these black points. These black points are giving you outliers. Okay. Here basically the blue part, the shaded blue part, is basically a range called IQR. Okay, it's an area called IQR, interquartile range. Okay. The first point in the IQR is your quartile 1, which is actually 25 percentile of the total data. Third quartile is basically, or the end point of this shaded area is called Q3. This is 75 percentile of the total data. And in between you have 50% of data, and the area is called IQR. Okay. Its formula is, when you want to calculate this minima and maxima point, what you have to do is you have to apply formula called Q1 minus 1.5 into IQR. And if you want to compute this point, Q3 plus 1.5 times of IQR. And all those data points which are beside Q3 or the extrema point or the minima point, those points are called outliers. So with the help of box plot, what you can do is you can identify the outliers present in the data. This is the outliers, like majority of the people having age 65 are normal to the data. Beyond 65 age, it is expecting that they are outliers in the model. Okay, they are outliers. This is with respect to your Titanic data set only. है ना? Like if I would have to analyze well data, तो obviously मुझे data change करना पड़ेगा, and then correspondingly I have to also see what type of plots would be suitable for that particular column. If the column is of real wala, so I could not apply table your bar chart. Obviously I have to rely on this histogram plot only. Okay, so that's why I like differentiated into two sections, the numerical or categorical data. Okay, then you can also go for some statistical operations, basic statistical operation like minimum kitta hai, maximum kitta hai, what is the mean value, and the skewness. I hope you know skewness. Skewness is something where imagine an ideal normal curve. If it is shifted left, so that is left skewed. Okay, and if it is shifted right, it is right skewed. In fact, I'll show you with the, like, when I'll switch on to my iPad what I mean to say about the skewed data or skewed. Right now it's 0.389, so it is actually skewed towards the left side. Okay, mean se zyada hai right now. Like mean is what? Mean is your, you can see mean value is 29. Okay, and it's skewed towards 0.389. So it is like left skewed. You also have right skewed data. So skewed is something which gives you an idea about the imbalancing. Okay, you have balance, like majority of the data belongs to one section and the minority belongs to the other section. Okay, that is what we can do with the skewed. This is an example. These are the plots which are an example of univariate analysis. What I have is, like, you have one additional library which is very, like, you need not have to do all these operations individually. Okay, See, this is other plot, scatter plot. This is also like, before this, I was analyzing column by column, each column individually. And I was naming it to be a univariate analysis because all the analysis that I was doing on a single column. If you have, or if you're analyzing two or more than two column, now you are in a situation where you have to apply multivariate analysis. And the first example for that is your scatter plot. What you're doing is you're actually analyzing two variables over here. Like this example is on data set, which is explaining about tip, how much tip that waiter got in a total bill. Okay. And in fact, you need not have to go into the much details. Okay. You just see this scatter plot where it's a relationship that shown by total bill and the tip. Okay. And you have various dots represented by your cross marks. You have sphere. Okay. Then you have long sphere, like thoda sa bada sphere hai, and then small. So these are actually the class labels too, like those columns, and they are represented by the various class labels. So you have scatter plot, you have some bar plots, this plot, heat map plots, okay, cluster map. Like there are various plots through which you can analyze two or more than two columns at one go. And this is what we call multivariate analysis. Okay, I'm not going to run all the commands. What I'll do is I'll again give you this Jupyter notebook to you, and you simply run these codes, run the cell each cell individually to get the corresponding output, and just have a look see what would be what you can get from the plots. Instead, I said that I have a very beautiful. Madam, just ये वाला हो गया, बस उसके बाद है. Instead, what we can do is we have a very beautiful library called Pandas Profiling. Okay, Pandas Profiling. Instead of like running the first two Jupyter notebooks, what I'll do is I'll run this Pandas profile in the same data set, Titanic data set. Let me run and show you. This is a command. If you don't have Pandas profile in your library, it will automatically install the Pandas profile. Because since I already installed it, so requirement already satisfied. Okay. Then let me show you the output. It's running right now. What it will do, it will generate an output.html file carrying all the univariate and multivariate analysis in a single HTML file. I'll show you. And you need not have to do these many exercises, like for every column you are going to plot box, dist, and not like, see, I'll show you just a minute. You know, it's running, summarizing the data set. Done. Generating the report. Done. Export report to file, 100%. Okay. Now, when I go back to my home, the mother folder, what was the HTML file name? I guess output.html. Where it is? Yeah, output.html. Let's see. This is your same data set that I have uploaded. It says that total number of variables are 12, observations are 891. If you remember, how many missing cells are there? 8.1%. Duplicate rows, zeros. I did it by like command by command manner. And Pandas profile, what it does it in a single go. It also gives me the corresponding like chart also. See, यहाँ पे chart भी आ गया. You have survived wala. How many survived? 342 people were survived and 549 people died. Then passenger classes, 491 people belong to class 3 category, 216, 184. You have plot as well as there are corresponding statistical values as well. Okay. See, you have histogram plot for the age as well. Okay. Then see, you also have the scatter plot between passenger ID to fare, passenger ID to passenger ID, passenger ID to age, sibling, parent, age, sibling. It's sort of interactive HTML file which was generated by this pandas profile to investigate the various type of data available in my data set, various types of attributes. Okay, I do also have the correlation chart right now. The spearman, like these are various types of correlations that you can drew from the data set depending on the attribute type, because attribute types are also categorical sometimes in real. So real wale pe you will have spearman, categorical pe you have to have crammer, देखो इसे categorical पे work कर रहा है. Okay, and then so on. This colors of the your grids are indicating values from 1 to -1. I said that positive correlation है, negative correlation है. So with a single pandas profile, I can actually analyze my data column by column in a univariate as well as a bivariate manner. Okay, I'll stop at this point. We'll resume with the initial data pre-processing in the next session. That too with handling the missing values with the help of data imputation. Thank you. Thank you. If you have any doubt, you can ask the doubt regarding this session. After 15 minutes. Okay, you can have 15 minutes of break, and after 50, like it's 11:27 right now. We will be meeting 11:45 sharp for the next session. Thank you.